Welcome to The Explainer. I am absolutely thrilled to have you here today because we're looking at a topic that fundamentally touches every single person on this planet. We are talking about how cutting-edge technology is actively transforming our global food systems. And look, this isn't just about global economics, right? It's literally about what ends up on your dinner plate and how much it costs. We're going to explore how artificial intelligence, satellite data, and digital innovation are merging with the world's oldest profession, agriculture. It is just an incredible story of human ingenuity meeting one of our absolute greatest survival challenges.
Okay, let's dive into this. 9.7 billion. That is the staggering projected population of our planet by the year 2050. Just imagine the sheer volume of food required to sustain that many lives. We're at this incredible historical crossroads right now where climate shocks, geopolitical conflicts, and economic volatility are all colliding with this massive demographic pressure. We literally cannot afford to feed the future using the methods of the past.
To really understand why, we have to grasp the massive resource strain of our current systems. Take a look at these numbers from the UN's Food and Agriculture Organization. Right now, agriculture accounts for roughly 70% of the world's freshwater withdrawal. It generates about 1/3 of all global greenhouse gases. And despite eating up all those resources, it still leaves over 638 million people chronically undernourished. But what's incredibly striking to me is that smallholder farmers, those working on fewer than 2 hectares of land, produce roughly 1/3 of the world's food, yet they are the most exposed to unpredictable extreme weather events and volatile prices. The urgency of these intersecting crises simply cannot be overstated. So here is our roadmap for today. We're going to frame the crisis, introduce precision agriculture, see how we adapt to climate change, examine some real-world solutions, and finally explore the future of farming. Let's get into it.
Section 1. The Agro-Food Systems Crisis. Basically, why our current food systems need an urgent upgrade.
Moving on to Section 2. Enter precision agriculture. We're shifting from generalized farming to data-driven decision-making. As we just saw, climate shocks and economic volatility mean our traditional, sort of broad strokes approach to farming is just no longer sustainable. We are hitting the absolute limits of what our water and soil can provide under the old rules. So the necessary paradigm shift here is digital agriculture. But what exactly is precision agriculture? Well, it's a modern farming approach that uses real-time data, analytics, and technology to optimize every aspect of the agricultural process, maximizing yield while minimizing waste. It essentially takes the guesswork out of growing food. Instead of treating an entire field the exact same way, a farmer treats every single square meter exactly how it needs to be treated.
And this brilliantly illustrates the stark difference. Traditional farming relies on generalized reactive techniques. You see a pest, you spray the whole field. You think it might be a bit dry, you water the entire crop. It just results in heavy resource consumption. Precision agriculture, on the other hand, relies on tailored, predictive insights. You exactly which corner of the field is dry, or which specific plants are lacking nutrients, and you deploy resources only there, completely driven by real-time analytics. It is literally the difference between using a sledgehammer and a scalpel.
Now, this shift doesn't just happen by magic, right? It's driven by a highly integrated tech ecosystem. There are 4 main pillars here. First, the Internet of Things, or IoT. These are ground-based sensors constantly collecting real-time data on soil moisture, temperature, and plant health. Second, artificial intelligence, specifically machine learning algorithms that crunch all that sensor data to predict weather patterns, pest infestations, and crop diseases. Third is remote sensing, using satellites and drones to provide high-resolution, wide-scale monitoring of crop health from above. And finally, automation and robotics, AI-powered machines like autonomous tractors and robotic arms that actually execute the physical tasks, from precise weeding to targeted harvesting.
Now, what's really interesting about this slide is how logically these distinct technologies map to specific farming functions. Think of it like a body. Remote sensing is your big picture data gathering. It's your eyes in the sky. Artificial intelligence provides the brains, the predictive analytics telling you what that data actually means. IoT sensors give you ground truth monitoring, the vital signs of the earth itself. And robotics, well, they provide the muscle, the task execution. When you integrate all of these, they create a seamless, closed-loop system of continuous improvement.
Which brings us to Section 3, Adapting to Climate Change. Using algorithms for smarter sustainability.
Because, let's be real, increasing yield is only half the battle. The other half is ensuring our food supply can actually withstand the erratic and severe impacts of a changing climate. So how exactly does AI drive this climate adaptation? Well, step 1, forecasting extreme weather. AI models analyze massive data sets of historical climate data to forecast extreme weather events like droughts and floods with unprecedented accuracy.
Step 2. Adaptive crop planning. AI decision support systems actually help farmers select the specific crops and seeds best suited for their shifting local climatic conditions. And Step 3. Mitigating disaster risks. By deploying early warning systems, farmers can harvest early or put protective measures in place to save vulnerable yields. It completely shifts farming from a reactive gamble against nature into a proactive, predictive science.
But hey, it's not just AI. Remote sensing plays an equally critical role in environmental conservation. And trust me, it is not just about taking pretty pictures from space. Remote sensing actively monitors deforestation and tracks land use changes to prevent illegal farming activities. It detects leaks and inefficient irrigation systems, which is absolutely crucial for water conservation. It even tracks greenhouse gas emissions and carbon sequestration, helping us measure the true carbon footprint of agricultural activities. And it maps entire ecosystems to protect biodiversity. From space all the way down to the soil, it tracks the health of our environment.
Section 4. Global Solutions in Action. Let's look at some real-world proof from the UN's Food and Agriculture Organization.
You know, it's really easy to look at this tech and think it's just theoretical or maybe it's only for massive, wealthy corporate farms. But that is simply not the case. Let's pivot to some real-world proof driven by the FAO and their global partners to see how this is being deployed right now. First up is the Hand-in-Hand Geospatial Platform. This is a massive effort by the FAO to integrate data sourced from public, private, UN, NGO, and space agency partners. It pulls together unbelievably complex data on soil, land, water, climate, forestry, and even economics into a single, highly interoperable tool. By leveraging cloud computing and machine learning, it enables unprecedented cross-sectoral insights. In simple terms, it takes siloed information and turns it into a master playbook for global food security.
Next is ACES, the Agriculture Stress Index System. Think of ACES as a global early warning system. It uses satellite-based remote sensing data to monitor cropland and grassland globally, detecting areas with a high likelihood of dangerous water stress and severe dry spells. It essentially simulates the analysis of an expert remote sensing scientist, but simplifies the output so that non-experts can use it to spot an unseen agricultural drought way before it destroys a region's harvest.
Now, let's zoom all the way in to the individual farmer level with FAMOUS. This is a truly tangible application. Fall armyworm is a devastating pest. The FAMOUS mobile app allows a farmer to use their smartphone's camera, utilizing AI image recognition, to identify microscopic evidence of this pest on a single leaf. It gives them immediate advice on infestation levels and then maps that data globally to give real-time analytics to analysts and decision-makers. It literally puts a world-class entomologist right in the farmer's pocket.
And then there's WAPOR. This is an open-access portal that uses remote sensing to fiercely monitor real-time water productivity across massive, drought-prone regions in Africa and the Near East. It tracks key variables like actual evapotranspiration, which is essentially how water moves from the soil and plants into the air, at incredibly high spatial resolutions. It really helps countries identify water productivity gaps and propose solutions to reduce water stress equitably.
Section 5. The Future of Farming. Democratizing digital agriculture for every farmer. All of these tools are incredible, sure, but they mean absolutely nothing if they only reach the top 1% of the world's farmers. As we wrap up, we really have to talk about bridging the digital divide to ensure these tools reach those vulnerable smallholder farmers we talked about at the very beginning. The FAO is tackling this through a federated, decentralized framework designed to democratize AI. It has three main components. First, the AI Sandbox, an experimentation tool and safe space for innovators to validate hypotheses, test market fit, and prototype solutions without massive upfront risk. Second, the STI Portal, a science, technology, and innovation network that connects local countries with trusted digital agriculture experts so people aren't starting from scratch. And third, innovation hubs. These are national and regional matchmaking and deployment centers. They take tested concepts, connect them with policymakers and investors, and turn prototypes into real, scalable implementations right in the communities that need them most. So the crucial point is perfectly captured in this powerful quote from the FAO's Innovation Roadmap. The system that feeds humanity is overdue for an upgrade. It just encapsulates the immense pressure we face with a growing population and a warming planet. But it also highlights the incredible, proactive opportunity we have right now to change the trajectory using artificial intelligence and remote sensing.
Which leaves us with a final thought to ponder. As precision agriculture continues its rapid evolution, reaching further into the developing world and becoming more and more sophisticated, will the future of farming be driven by data rather than dirt? Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I will see you next time.